Number 4 example out of the 3.4 lesson is one worth going over carefully. They give you that x squared plus y squared equals 3, and they have to find the second derivative. Keep in mind this expression because it'll come in handy later. What we're going to do is we're going to find y double prime in terms of y. Now all that means is that you want to get in your final answer only y in the answer, no x's. So our first step is going to be, as I show right here, to take the derivative of each term, and I set it up right down here. Now after I've done that, then I'll take the derivative of each one of those terms. X squared's derivative is 2x. Y squared is going to be 2y dy dx because y is a baby. It's a function name for something going on with x, and we don't know what's going on with x, so we just put dy dx. And then over here the constant's derivative is 0. Our next step is to begin to isolate dy dx. So I took my 2x and I moved it to the other side. Then I divide by 2y, and I now have what the derivative of y with respect to x is. It's negative 2x over 2y, or simplified, which you should do, negative x over y. Now we have to take the derivative of this to get the second derivative. So to do that, we're going to use a quotient rule. And the way I write the quotient rule is to say d squared y dx squared as the notation for the second derivative of this function. And I'm going to announce what f is, announce what g is, and then I set up my table. Now when you're setting up the table, what you put right here can be a variety of things. It's important though that you say somehow you're taking a derivative. What you put up here is always the correct generic formula. And a lot of kids tend to get this wrong right here. They tend to put different orders, get things mixed up. Always have it in this order. Then you got your t-bar. Here's f, f prime, g, which is the y value. We said g was the y value. That's also the baby. So let's take the derivative of the baby, and the derivative of the baby is dy dx. The reason we don't then take y out of there and take the derivative again is because we already took the derivative of the baby. We don't need to do it again. So now we put everything into the formula. I like to put parentheses down first, then I fill in the parentheses. And when I do, I've got this dy dx sitting out here. Now remember, we found what dy dx was back here. So we're going to allow that value to replace dy dx right here. And when I do, it's going to help get rid of some of the confusion in the problem. Because now what I've got is negative y right here. I have positive x times the value negative x over y right here. And that's divided by y squared. Now if I will multiply everything by y over y, then that's going to be a form of 1. So I haven't really changed my rational expression, but I'll get rid of the denominator y here. So y times this term will leave me with x squared, and y times this term will give me a negative y squared. Y times the denominator gives me y cubed. Now at this point it looks like we're stuck because we still have x's and y's together. But remember that this looks an awful lot like a circle. If I could just extract the negative, which I can, it'll leave me with y squared plus x squared, its opposite value divided by y cubed. Remember I told you at the beginning that what our given expression was would come in handy? Well, we know that y squared plus x squared is equal to 3. So now we can replace y squared and x squared with a 3. And that's your final answer. Notice our final answer is in terms of y. There's no x involved. And that's why they say your final second derivative has to be in terms of y. Hope that makes sense. Remember, we have a quiz on this problem and also on number 3 over here. Remember also on number 3 that you do that the y prime really should be written as dy dx. And also recall that this is not in the order that we use. We use the order of f prime g plus fg prime. And if I'm not mistaken, they reversed these two when this was written right here. Keep that in mind, and you should be able to work your way through the problem all the way to getting to what the actual slope is that is at 1, 2. Good luck. We'll see you next class.